Alright, so this is Unit 5, the second part of Unit 5. And what we're going to look at here is chemical reactions and how to balance them. And then we're going to look at the different types of chemical reactions and how to identify them. So first, before we do that, let's just quickly run through the different parts of a chemical reaction and then how to balance them. So what is a chemical reaction? A chemical reaction is really another way of saying a chemical change, and that's when one or more substances are changed into new substances, which means that bonds are broken or bonds are formed. Now be careful with this because it doesn't mean that you form different elements than you originally had. It just means that the original elements are just rearranged. So let's take a look at a simple chemical equation. If you look at it, and again, let me get my pen going here. Okay. Remember how we said that you break it apart into two parts. You split it where the arrow is. And as you can see, the reactants are on the left side. There's two reactants. If you look at that, it means AQ means aqueous. And what that means is, and you should write this, is that you have HCl in or mixed with water. Okay? The zinc, the S, means that it is solid zinc. It's in the solid phase. And those are the reactants. The arrow means yields or produces. And then you have the products. And in this case, you'll notice that, there are two products. H2 is a gas, and again you have another aqueous solution, but it is not balanced. Now how do I know it's not balanced? Well, it's not balanced because if you look at the arrow, it does mean yields, but in a way it also is an equal sign, meaning that whatever's on the left side should be equal to what's on the right side, and you'll learn that that's called the law of conservation of mass, meaning you should have the same number of H's on the reactant side as you do on the product side, etc. Notice that you have two H's on this side, but you only have one H here, so this is not a balanced equation. So it does not follow the law of conservation of mass. And all equations must do that. The law of conservation of mass simply states that the masses of the reactants must equal the masses of the products, or matter can neither be created nor destroyed. Alright, so let's take a look at this equation in a little bit more detail. As we said before, that this equation, as we said, does not follow that law, and we pointed out exactly why that is. This reaction does not have, for example, the same number of H's on both sides. It doesn't even have the same number of chlorines on both sides. It does have the same number of zincs, but all the elements have to be balanced. So this reaction does break the law of conservation of mass. So again, as we said, the law of conservation of mass says that matter is neither created nor destroyed, and another way of putting it is to say that the mass of the reactants must equal the mass of the products. So let's look at this equation a little bit more. Again, let's say, for example, what do we mean by the mass of the reactants? Well, let's say that we had, just going to make up numbers here, let's say we had 15 grams of HCl and 10 grams of zinc. And we obviously that adds up to 25 grams. That would mean that the total mass on the right side should also be 25 grams, correct? So let's say, for example, I had 5 grams of hydrogen. What would be the mass of the zinc chloride? Well, if I have 5 grams and this has to add up to 25 grams, it would be 20 grams. And that's basically what we mean by the law of conservation of mass. Now, do we have to use these numbers? Absolutely not, because what happens is we know that if we have the same number of H's on both sides and the same number of chlorines on both sides and the same number of zincs, those numbers will automatically come out correct. So we don't really need to work with those numbers, but they do sometimes ask you to make sure, understand that the mass of the reactants is the same as the mass of the products. So let's take a look at how to balance equations. There are a lot of different ways. If you go on the internet, you'll see different ways of doing it. Basically, what I like to do is, as I said before, is I like to just split the equation right there. And before you balance it, a couple of things to remember. The only things that you can change are the coefficients. You cannot change subscripts. So when you see, like, for example, this 2, that 2 cannot be changed to anything. And these are 1s. We just don't write 1s here, but those cannot be changed either. The only numbers that can be changed are the numbers that are in front, which are called the coefficients. That is it. You can't add parentheses. You can't change subscripts. You can only change these numbers in front. So before we go, let's just quickly run through and look at both sides. So on the reactants, we have 1 hydrogen, right? We have 1 chlorine, and we have 1 zinc. Okay. On the product side, you can see that we have 2 hydrogens, so already we know it's not balanced. Again, we have 2 chlorines, as you can see here, and 1 zinc. So there's different theories about how to go about balancing it. I basically just start from the first element and work my way over. If that doesn't seem to be working, then what you would do is you would pick the element that is the most out of balance, in other words, the most different, and work with that. And it just takes practice. So how do I change this? Well, what you have to remember is this. If I put any number that I put here goes for both of these elements. It has nothing to do with the zinc because they're separated by a plus sign, but any coefficient I put here goes for the H and the Cl. The coefficient I would put here goes for the zinc. The coefficient here only goes for that, and the coefficient here only goes for these 2 elements. So you have to be very cognizant of that. So I need to make sure that the H's and the Cl's are balanced. Well, it's very simple. If I put a 2 here, I change that from a 1 to a 2. That now gives me basically this. This is what it means. It's kind of similar to putting parentheses around it and putting a 2 on the outside. This now gives me 2 H's and 2 Cl's, which automatically balances the equation. I have 2 H's on both sides, I have 2 Cl's, and I have a zinc. That means that this is a balanced equation, so this does now follow the law of conservation of mass. One of the things that they do on the Regents exam is, especially on the multiple choice questions, is they will ask you to determine the sum of the coefficients. That's their way of finding out if you can balance an equation by using a multiple choice question, because they figure if you have the sum of the coefficients correct, you probably balanced it, which means you have to add all the coefficients even if they're 1s. So the coefficient is a 2 and a 1 is 3, plus another one is 4. There's no 1s, remember we write them. We don't write them, and 1 is 5. So the sum of the coefficients is 5 for this one. 2, 1, 1, and 1. That adds up to 5. So you should practice that also. Okay, here's a couple more, and then I don't want to take forever for doing this. Alright, so the elements are N and just H. There's an extra box. You don't need to do this diagram, this box, if you don't have to. I have 2 N's on this side, and I have 1 on this side. I have 2 H's. Remember, we're splitting it here. I have 2 H's on this side, and I have 3 H's. Well, both elements are not balanced, so let's see. I have 2 nitrogens here. I only have 1 here. If I put a 2 here, that is now going to give me 2 N's. However, because the coefficient counts for both the N and the H, it also, remember what that means, it gives me 2 ammonia molecules. Okay, so that actually now gives me not 3 H's, but 6 H's. So by balancing the nitrogens, I threw off even more the hydrogens, but that's okay because now I can go on this side. If I put a 3 here, remember what that gives me? That gives me 3 of these H2 molecules, which gives me 6 hydrogens on this side. Now the nitrogens are both 2, and the hydrogens are both 6. It is now a balanced equation, and the sum of the coefficients would be 6. There's a 1, a 3 is 4, and 2 more is 6. Okay, so let's do this next one. We only have 2 elements. We have aluminum, that doesn't go there, aluminum and oxygen. I have 2 on this side and 3 oxygens. On this side I have 1 aluminum and 2 oxygens. So let's see. Well, we can start with the aluminum. I put a 2 here. That doesn't do anything to the oxygen because they're separated by a plus sign. So that gives me 2. Doesn't help me with the oxygens, however. I have 3 on this side and only 2 here. Now the problem you're going to run into is there's no way for me to get 3 oxygens here because whatever number I put here gets multiplied by 2, and these numbers, coefficients, have to be whole numbers. So I do the next best thing. I have to look for the lowest common multiple of 2 and 3, which happens to be 6. So I need to somehow get 6 oxygens here and 6 here. So in order to get 6 oxygens here, that's easy. I put a 3 here because that would give me 3 O2 molecules, and that would give me 6 oxygens. Now, I can't change the 3 here. I can only put another number here. So what times 3 would give me 6? I'd have to put a 2 here. That gives me basically now 2 of these aluminum oxide some substances. Now, if you count them up, that does give me 6 oxygens, but it also did what to the aluminums? It now gives me 4 aluminums. Oh, wow, did I screw up? Not really, because I can now go back and change this 2 to a 4. That gives me 4 aluminums, and remember, because there's a plus sign separating them, this 4 has nothing to do with the oxygen. So now the coefficients are 2, 4, and 3, and when you add that up, it comes out to 9. And that is how you balance equations. And you should do the next 2 on your own. And we can definitely go over those in class if you need to. Okay, and that's it for this lesson on